Okay, y equals 4x cubed, tangent of 4x cubed. So based off of this, if you want to find the derivative, can you identify what we have to involve here? Product rule, right? You see that tangent of 4x cubed, that's one expression. A little bit of chain inside, but that is distinctly different from the 4x cubed. So we got to go through product rule. Okay. Okay, try that. I'll work alongside you guys. Any questions with one? Okay.
You can't really simplify it too much.
Yeah, I'm not going to care too much about simplifying. But we could take out a GCF. That's what I did on the key. But just understand where the x's can be combined, where it cannot. We can't do anything with what's inside the trig function, but whatever's outside of it, those are candidates to move together or combine together. All right, number 2, we're also asked to find the derivative. What's involved here? Motion rule, yeah. So we're going to recall the new rules for cosecant and cotangent. It's going to look messy, but it's okay. We can just leave everything the way it is once we build our derivative out. I'm not doing much to clean up here. I'm just putting the coefficients out in front. But not much more we could do. These notations are interchangeable, either putting the square outside or you can put the squared between. Okay, questions with 2? Okay, number 3. Cotangent of y is equal to 3x sine 5x. What do you notice here? Let's get the product and implicit because y is not by itself, right? There's something attached to y or y is inside the equation here. We got to keep track of our dy dx. Product rule there. Okay, so cotangent of u is negative cosecant squared of u times u prime, and y's derivative is dy dx. Okay, f prime g plus f g prime. And then sine's derivative, sine of u becomes cosine of u times u prime. Okay, in terms of cleanup, to solve for dy dx, we're going to divide that negative cosecant squared y over. And I'll just do a little bit of cleanup here. I can merge the 3x and 5 together. And that's about all I can do in the numerator. Oops, sorry, what am I doing? Sorry, divided by negative cosecant squared y, dy. Any questions with 3? Okay, number 4. It says dy d theta. That means the same thing. It's just that now that just indicates that dy dx. Dy d theta just means I want to find the derivative of y with respect to theta. It just tells us that we have a new independent variable instead of x is theta, but it's the same process. We find the derivative. But I want to do something else. We're also going to find the second derivative as well. Okay. So once we find the derivative, we can see what we can do to move to the second derivative. Derivative is pretty easy because there's no product rule, there's no chain rule. It's just the derivative tangent, which is secant squared.
Do you have answers for this?
Yeah, we'll have 2 answers. Yeah, basically we're just finding f prime and f double prime. Yeah. Okay, so that's the first answer. Now, to get to the second derivative, is there anything that stands out to you in terms of what we should? Parentheses, that's right. That squared there is squaring the entire expression, but this is a shorthand form of saying that the entire secant is squared. If you don't put that square outside a set of parentheses, you're not going to be able to see the chain rule as well. That's going to lead to potentially not getting the correct derivative. So anytime that you want to find the derivative with that shorthand form there, take the time. It only takes a second, but it's worth it to rewrite the problem in this form. Now, if you can get the right answer without writing in this form, that's great. I won't take off points if you don't write it in this form, but I'm just letting you know that 90% of the time, if students did not take this initial step, the chances are a lot higher that they're not able to see that full outside inside portion, and the derivative is not going to come out.
Do you include the data?
That's right, include theta, but we don't include the 4/3 because 4/3 is outside of that secant expression. Yeah, any trig function always has to have some variable attached to it. A secant, tangent, trig is never standalone. It's always involving something. It's always trig of an expression, right? That trig ratio of an expression. Okay, so we know there's chain rule involved. There's an outside inside portion that we got to make sure we involve. We got to take turns with each derivative. All right, what's outside's derivative? Not 6/3. 8/3. 8/3, right? Okay, so 8/3 raised to the first power. Inside portion stays intact. Okay, we took care of outside's derivative using power rule. Now we're ready for inside, but inside is going to have to be in a separate space. We can't do inside derivative here. It's got to be in this own space. What's secant's derivative? Secant, theta, tangent, theta. Okay, ready for cleanup? Eight-thirds. I can put the secants together, make it secant squared. Oh, I'm sorry. I copied the wrong problem. Yeah, I did. Let me just show you what I meant to do here. It's 4/3 tangent 4 theta. Okay. We don't have to rewrite it again, but I just want to kind of show you what we should have done here. Tangent of u becomes secant squared u times u prime. So there's going to be a 4 that's going to be left over, which is going to become that 16/3 in front. And that 16/3 in front is going to have to go through power rules. 16/3 times 2, secant 4 theta, and then secant u cotangent u times u prime. So that 4 is going to have to be involved in the derivative. So sorry, I copied the problem wrong here. I didn't include that 4 theta. So a lot of the chain rule portion were left out, but that's okay. You don't have to go back and redo everything. Just want to point that out. Right, your key is on page 16. So okay, let's look at number 5. Find equation of the tangent line to the curve. So tangent line equation, we need to find order pair, we need to find slope through the derivative, and then point slope form. All right, let's get our derivative. Cosecant. Cosecant's derivative is negative cosecant cotangent. Okay, so we're going to gather our information, our order pair and our slope information from unit circle values. I'll do the order pair first. Right, so the original x value gets inserted into the function, into the original function. Maybe you have a hard time thinking about what cosecant is, but just think in terms of what sine is, and they can flip that, right? Let's think about what is sine of 2 pi over 3. We know second quadrant, sine is going to be positive. It's going to be in that pi over 3 family. So if you guys remember, what's sine of pi over 3? Yeah, root 3 over 2. Right? And it's positive in the second quadrant. So we know sine is root 3 over 2. So therefore, cosecant of 2 pi over 3 will be what? If this is sine's ratio, then what's cosecant's ratio? 2 over root 3. Right? Leave it like that, or you can write it as 2 root 3 over 3. Either way, I'm not going to ever count off if you have a radical in the denominator. So that's our y value. That's our order pair. Next up, we're going to find our slope. So we know that at pi over 3, my order pair is going to be 1/2 root 3 over 2, right? That's my order pair at pi over 3. Cotangent, we know it's going to be negative in the second quadrant. Cotangent, you can think in terms of the reciprocal of tangent, or you can think in terms of, oh, cotangent is just x over y. Instead of tangent being y over x, cotangent is x over y. So I can just flip, I can just look at my x and y values, 1 divided by root 3. That's cotangent. So we know cosecant of negative 2 pi over 3 is 2 over root 3. I'm just going to copy that down. So negative 2 over root 3. And the cotangent is negative 1 over root 3. Right. If I divide these two, the 2's can just go away. I just focus on the numerator, 1 divided by root 3. So if I clean this up, my slope is just 2 over 3. Okay, so I have my slope, I have my ordered pair, point slope form.
Always point slope form.
Yeah, always point slope form. I mean, you can put it in other forms too, but this is the easiest, most efficient way to get to a linear equation line. Okay, number 6, particle motion. But really, particle motion on the quiz will just be like this, where you're asked to go from position to velocity to acceleration. So you have the position function given. We're going to find the acceleration, so we got to find the velocity function, then find acceleration function, and then we can plug in 3 power 4 into the acceleration function. All right, try number 6.
So going back to like particle motion.
Yeah, but just it's just basically finding the second derivative. We're not going to do. It's not going to be any more complicated than this particle motion. We're not really getting into the increasing, decreasing speed, all that. It's just this.
So like the second derivative rate and velocity first.
Velocities first, right? Okay, cotangent derivative is negative cosecant squared u times u prime. Okay, look at the form for velocity here. We got to keep going to get to acceleration, but before we find the derivative, again, will be a very useful step here. Yeah, let's rewrite it. Okay. Spend the time to rewrite it. That way you can clearly see, okay, I need to worry about chain rule designation here. Outside derivative times inside derivative. Outside derivative was outside derivative. -4 parentheses to the first power. Times inside derivative, cosecant derivative is negative cosecant u, cotangent u times u prime. Clean that up and then replace every t with 3 power 4. Now I have a -4, a -1, and a +2. So if I put all that together, I'm going to get a +8.
And 2 to the front is most better.
That's right. Okay, let's replace every t with 3 power 4.
Just working from.
I just merged these together. You don't have to. Cosecant 2t, cosecant 2t. I just merged to be cosecant square 2t. Bring it out again as I remember. So 2 times 3 power 4. Right, so cosecant, we know, is the reciprocal of sine. So sines. Morgan's not here. Cosecant is reciprocal of sine. So sine, the 3 power 2 is -1. So if I flip -1, I'm still going to get -1. So there's just -1 here. Cotangent of 3 power 2, you know the order pair at 3 power 2 is 0, -1. And so cotangent is just x over y. So x over y, 0 over -1 is 0. So I'm going to get anything times, it's going to end up being 0 because that 0 is going to cancel everything out. So 8 times -1 squared times 0 is 0.
How do you get 3 power 2 for that?
So I got 3 times 2 times 3 is 6, 6 over 4. I reduced 6 over 4 to be 3 over 2.
And for your 1, 2 use them.
Same thing, yeah. 2 times 3 over 4 is 6 over 4, which is 3 over 2.
And if you times we can actually like simplify it too. You usually can't simplify it.
It depends, but I mean, if I give you a problem like this, it'll always be a unit circle value. So you always want to reduce so they can actually get to a measure that you recognize. Yeah, so you do want to reduce. Otherwise, 6 over 4 may not be as recognizable as 3 over 2, 3 power 2.
But you mostly get to like a real number.
That's right. Yeah, you'll always get a real number with these problems like this. Okay, let's see if we can spend a few minutes to start page 17. What would you do first with number 1?
Do this really.
Yeah, you would rewrite it. Rewrite it as what?
One that's been.
Cosecant raised to the 3/2, right? That square root is a denominator 2. Yeah. And then you clearly see chain rule, right? Okay, go through chain rule. Outside's derivative times inside's derivative.
What do you mean there's a pi involved in that?
Think of pi as just the coefficient. It's like a 3 or 4 or 5. So what's the derivative of 7 minus pi x when you get to it? Just negative pi, right?
Oh, yeah, BCX goes.
X goes away, right? Imagine it was 7 minus 3x, it'll become negative 3. So 7 minus pi x will just be negative pi. Outside's derivative, we go through power rule, 3/2 parentheses to the negative, or 3/2 parentheses to the 1/2. Keep the inside intact. Multiply it by the inside's derivative. Cosecant u becomes negative cosecant u cotangent u times u prime. Do a little bit of cleanup here. I'm going to push all the coefficients out in front. 3 pi, negative 3 pi over 2 is in front. Now I see a chance for me to combine some things here. These are both cosecant 7 minus pi x. I can just add the exponents, right? This is raised to 1/2. This raised to the first power. 1/2 plus 1 is 3/2. And then finally the cotangent is 7 minus. Okay, any questions? So tomorrow we're going to be working on this. So the homework, let us do the Monday after break, which would be page 17. If you're here tomorrow, we're just going to work through it. But if you're not here tomorrow, then I'll just check all the homework Monday after break.
This is all in Wednesday.
Yeah, quiz is the following Wednesday. We have Monday still to review. Tuesday, we may need to start a new topic, and then quiz will be the Wednesday after break. Okay, come get your phones.
Somewhere we're adding after Thursday.
We have 3 more topics. We have curve sketching, related rates, and arc trig derivative. So we have 3 more lessons after the break.
There's more like cone problems.
I'm sorry?
Is there like cone problems? Related rates?
No, actually, with related rates, it's just be right triangle problems.
Oh, okay. So we can. Let's say.
Oh, you can plus there. Yeah, there. Yeah, there, yeah.